Hey everyone, today I'm going to be working on a Galaxy S3 that was sent here for repair. Yeah, that's right, I'm still fixing the Galaxy S3. Well, the first one that I did today was actually for data recovery, so I was a heck of a lot more careful with it. This one had a OTG fan, I don't know if that's the right thing to call it, a fan plugged into the bottom of it. The phone was on when the fan was plugged in, and as soon as the fan got plugged in, boop, phone went off. So let's have a look at this thing. I'm going to show you how it is that I narrowed down this type of problem. The first thing I did was took measurements at the battery terminal. I put my ground on ground and my positive on positive. And I am checking in ohms mode. And on this Galaxy S3, I get 1,500 ohms. I get 1.5K of resistance. So if we compare that to a known good Galaxy S3, across the battery terminals here, ground on ground, positive on positive. Initially I get 1.5K, but then we go open circuit, and then our resistance is up, we're at 15 mega ohms. And I checked it earlier, it trickles down, trickled down to about 10 mega ohms, but anyways, 10 mega ohms is a far cry from 1.5K. Let's kick that one aside. Now, I'm not going to pretend like I don't already know how to solve what is wrong with this phone. I've already did one of these today. They seem to be coming in groups. I've got another one on the way, so I figured I better make a video. But yeah, those little fans are crisping these things. Look at me reaching for a penelope screwdriver. I don't even remember what screwdriver to use on a Samsung phone anymore. I get a lot of people asking me, why just work on iPhones? Well, man, iPhones are profitable to work on. I imagine Samsung phones are too. I do a fair amount of Samsung phones, but it's not my cup of tea. I'm really trying to gear toward one specific type of device that will broaden the amount of problems that you're able to solve, because you start trying to work on too many different things, you got yourself spread out too thin, it gets really difficult to solve complex problems. And that's something that I've learned with with the job queue that's always jam-packed full of so much work that it's hard to do it all. And that is, it is difficult to learn new things whenever you're buried in so swamped that you can't see straight. Alright, we've just about got all the screws out of this. I am a little bit curious to see if this is the exact same problem as what it was here on this last phone. Now mind you, I did spend a bit more time narrowing this down on the last phone, but that's just how troubleshooting works. Somebody said to me the last time I posted an S3 video, who still works on it? Who still pays to fix an S3 or something? I don't remember what it was, but I'm finding out quite a lot of people. I was surprised. These last couple of deals. Now the last one was a data recovery. That guy, he really wanted his data. So that one's understandable. This one here is not so much data. This is just, I know this phone, I trust this phone. It's been a good phone. I'm not ready to upgrade, and geez, all I did was plugged in this fan attachment and poof. Seriously, you're going to make me look like a fool on my YouTube video? Alright. I've opened probably 100. No, more than 100. Oh, man. I don't know how many S3s I've opened, but the one or two that I open on camera are going to be totally different. And I'm missing my S3 tool that I always use right here. I got this dental pick that fits in there just right, fits in, and turn it, it pops right off. Alright. So, let's go ahead and take the board out of this thing. Now I'm actually skipping somewhat of a step right here. If I didn't already know what was wrong with this phone, I'd be hooking a power supply up here and seeing just what kind of a current draw we do get, because I measured 1,500 ohms. 4 volts isn't going to do shit through 1,500 ohms. That's like what? That's less than a milliamp, right? Anyways, it's a little bit. It's so little current that the power supply wouldn't, it just wouldn't do anything. So it is safe to hook power up through that, but Not in this case. So let's continue taking the board out here. I'll show you what I'm up against. Okay. And then from there, we are going to take the SIM tray and SD card reader off of it. Boy, I'm really missing that little pick tool of mine. Wonder what happened to it. That's my tool for pulling the S3 apart. Being very careful to choose areas here that do not have components to insert my tool. Okay, so the first thing I did with this OTG fan issue was I went looking all over the place. And the one particular one that I worked on, that diode right there that has BB on it, it looked like sort of it was a little bit glossy. It looked kind of like melted on one side. And what I was doing was, since I knew it was OTG, or something to do with power flowing from the battery back to the port, I started looking for pathways from the battery back to the port and racking my head on the schematics, and really was silly to not just hook power up to it and see what happened. But it was because I was being really dainty. You know, it was data recovery. I didn't just hook my power supply up to it and turn it on. So I started looking all over the place for anything between the battery connector and the charge port, and I've got a mix up between my different versions of schematics and different models of the phone. The ZXW tool only shows just like raw pinout. It doesn't show what the names of any lines are. It just shows you what's hooked to what, which is actually still pretty dang useful. So I did a little bit of banging my head against the wall, but in the end I put it aside and I came back to it and I realized I'm a dummy. I never actually hooked power to it, and that's because it was data recovery, and I was really nervous about it. So if we hook a ground here on ground, and initially I started off, because I was being careful, I set my power supply for 2 volts. Now this power supply that I'm using, the link is in the description. It's cheap, it works, but it's really crude. I want to advise against using this power supply, and the reason being, whenever you're adjusting the knobs on this thing, just the slightest little bit of movement is the difference in 1.5 volts or 6 volts. And it'll eventually get dirty pots to where the knobs are going to be scratchy, you know, like on an old audio amplifier, it's going to be a little bit scratchy. So it's going to develop this really erratic behavior and voltage. That power supply is going to be replaced really soon because I don't trust it. So anyways, we are set at 1.9 volts. And initially, let's see if we can cover this on my other camera here. Initially what I did is I came in and I bumped the positive line here with positive, and I noticed my power supply went straight to 3 amps. And it's like, whoa, what the hell? We're at 1500 ohms. How are we pulling 3 amps at 2 volts? Well, there's some switch, there's some transistor, there's something on down the line that's getting opened whenever the power is applied. So that was my first step in troubleshooting this thing. And as you've seen in my last Galaxy S3 video, my next step was laying my hand on the board and giving a little bit, you know, keeping a real close eye on my current. So I started feeling around for heat, and I didn't feel any heat at first. So then I flipped the board over and I felt a little bit of warmth, just like I am now. I'm trying to recreate this experience. Yeah, I could just act like I didn't already do this once today. And I started feeling around, and I felt heat building up, and then just like in my last video, oh man, just a hot spot all at once. So from there, I switch over to the microscope. This is a repair video telling the story of a repair. And I knew the heat was right here in this area. I mean, it was right here. So my next step was to take a Q-tip and a little bit of alcohol, and I just put a pretty good size, you know, just damp the top of all this stuff so I can see it whenever it dries. And then before it dries on its own, I came over and I bumped the positive again with my 2 volts, and you can see it dry off. It's still extremely difficult to tell which one it is. So we add just a tiny bit of power. Now remember, this line is a 4-volt line. So I'm at 2.9 volts. We're just under 3 volts. I'm going to re-wet this area. Now, mind you, I don't have to wet the area. I could just stick my finger on it, see which one burns me, but eventually you get sick of getting burnt. Oh boy, you see that one boil? You see who boiled? This one right here. It boiled really, really, really hard. The next thing I did was I grabbed the donor board, and let's see, that's the one I pulled it off of. Where's my, oh, I moved it. I got 2 boxes full of S3 parts here. That's going to be our good candidate. Same model. I'm not going to have to dig around and find this component. This is also a board that I know powered on and worked. I don't remember what was wrong with it. So as you'll notice, I'm not being near as careful with my donor board because I just need to get the job done, rip that shit off of there and move on. And then let's find our same component. Yeah, I'm basically recreating the repair I did earlier today. And I'm checking the back of the board to see if we've got any epoxy coated components. It's actually directly on the back side of one, so I'm turning the board in a way that I feel that my hot air is going to be blowing away from those. And the component that we're going after here is the 1694, whatever that is. I actually Googled that number, and I didn't, I Googled these numbers and I didn't come up with anything. So I don't even know what this is. Somebody out there is going to laugh at me for it, because this is most likely a very common fault here for Galaxy S3s that just die and never come back. And the way Samsung is, it's probably still a flaw right on out to the S15. Alright, so as usual, I'm working my temperature up slow. Sometimes I do this with flux, sometimes I don't. And I'm watching for that to move. Now I feel like temperature's up there, so there it is. You get a certain feel for this stuff, and you know right whenever it's getting ready to melt. Okay, so we have harvested that component off of a donor board. That is burning my hands. That was really smooth. Alright, so now we're going to have to put some new balls on this thing, because when we go to put this on the new, put this component on the board that we're repairing, it's going to need its balls. There's no way I could solder on the screen like that. Okay. But there was a time I thought I could, and I tried it. That was my first efforts. I built a microscope out of, what the hell? Look, I bridged every pin on the end of that. I built a microscope out of a retired CCTV camera. And that was my first micro soldering microscope. Those things actually focus really well up close. Alright, that's just never going to make me happy, so let's leave it just like it is. Now I actually don't have direct heat stencils for Samsung. And I thought I did all the way up until I went to reball this one this morning. I do have stencils for Samsung, but they're not direct heat stencils, and I'm not even going to try, because you have to have patience of steel to put balls on something with stencils that are not made to be heated with heat. So I hunted around here for a good long while to find one that matches, and I settled with this one right here. This is my iPhone 6 or 6 Plus template. I only use one of them. I think this is this, what is this? iPhone 6. The 6 Plus one's actually never been used. Man, I thought that one would line up, but it don't. So I wound up here on this big one here. Why does it feel so awkward? Something feels really awkward. Oh, it's because it's got crap all over the bottom of it. Look at that. Let's see, not this one, right? This one don't line up right. See, I thought that one was going to work, but it just don't. So ultimately, where was I? Lost on my stencil again. Okay, I went up all the way over here on this big guy here. Now I'm using my iron just to kind of pop these flux bubbles. I do clean these stencils periodically, but for the most part, it's Thursday. It's been a busy week, and I only use little parts of these things, so they don't get cleaned too terribly often. Alright, so we go good this way, good that way, okay. Alright, now it's flat on there. Yeah, before it was just, you could tell it was something was holding it. Alright, no flux bubbles in the way. Touch my finger with that solder paste. Don't make me look like an idiot on my YouTube video. You component I don't even know the name of. Now I spent a lot of time poking around all of the pins too. I'll talk about that here in a minute once we get the one off of the phone that we're actually repairing. So we're going to work this up sort of slow. Okay, let's hit this with a little bit of air and center all the balls. Not the best looking reball in the world because the balls are all really small, but they are actually fairly uniform. We're going to go with that. Alright, so we're going to sit that out of the way. And we are going to grab our customer's phone and move back over here out of that little flux puddle that I just made doing the reball. Okay, so we're going to find the component that's getting replaced. It's that one. I'm going to turn my board here in a way that I believe hot air will be traveling in a direction away from the underfilled components on bottom, so I'm trying to actually push my heat off away from those components. I'm laying a metal shield here just over these FPC connectors. Right, you know, here's your screen connector. I believe that's screen connector. Now, before we remove this chip, I'm going to be marking pin 1. Alright, see we got a dot up here in this corner. We've got a dot right here. So I'm going to mark that. Just a little dot that I know I'm not going to accidentally wash off with something. Okay, let's get their chip off of here. I'm going to start slowly heating this thing up. And I know where our underfilled components are here. They're facing, they're like back this way. And just when I start thinking we're getting hot enough, I'm going to start bumping it a little bit to see when it moves. There, we're moving, and we're up. And we're going to throw this one over here because it is going in the trash. Alright, now with this board hot, I'm going to put just a tiny bit of flux on that spot. And I'm going to smooth these pads off. Now, it's really common with this type of repair to pull an IC like that, or pull something off like that and just replace it, and put a new one on it, and have the same exact problem. So the next thing I did is I went through here with my voltmeter, and I clamped one side onto ground, and I went through and I started checking all of these lines and comparing that to ZXW tool with which lines it said was ground, because you can't actually tell just by looking at some of these. Some of them are ground, but they're not part of ground plane on the board, so it can be difficult to tell. So I went through here and determined that I didn't have any shorts to ground. I didn't have anything remotely resembling 1.6K. At least I don't remember that anyways. So from there, I had my chip ready to put on the board because I wanted to make sure I could salvage one of these and get one reballed and ready to go on before I pulled the one off the board. Because what if it wasn't the chip and I did all that for nothing? That would have made me feel really, really dumb. So here is the one that we reballed, and it's got too much flux on it for me to read the chip. I can't tell where the dot is at. And it's got a little bit of solder on it since I've been reballing in that same spot all day. Okay, so now we can see where our dot is. And you can also see it's a different chip, but that 1694 part, that matches. Okay, let's get rid of our fuzz. Look at a big long piece of fuzz. Ew. Alright. And hey baby. Oh, look at the size of that blob of flux on this thing just oozing out. It's because it's so hot in this room. And baby size dot of flux on the board. Turn the hot air station on and cool off. Okay. Now one thing I do appreciate with these boards is that they've actually got markers as to where your corners go. That's a pretty big deal. Oh, and I did also check the same measurement at the battery terminal without this component on the board. I don't remember what the measurement was. I know my 1.6K was gone. Alright, so we have the luxury on these to line them up with the little corners they give you for guides. And let's start warming this dude up because we are well close enough for this thing to pop up into place. Slowly. And it'll start to get a certain feel to it here. And I'm going to be moving in on it as it drops. Okay, that's on there. Remove heat. Only enough, just enough heat, man. You don't need a whole bunch of heat. I've got one of these here that is just, it's a really, really sad story, man. This guy really, really, really wants his phone fixed, and there's a dang good chance that I can fix it, but not with balls pushed out of everything, and you know, the multi-layered chips with the balls squeezed out between. Just no, 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 no. Alright, let's let this board cool off. And while it cools, we can have a look at the other side. Let's see, where was our chip at? Right there under this side. We can have a look here and see if we've squeezed. I mean, that chip is directly on the other side of this Qualcomm IC. And I see no signs of overheating. Blessed be thy hot air station. My cheap $129 hot air station. I love this thing. It is going on so many hundreds of repairs with stable, loyal service. If this thing if this thing broke on me like right now, I would drive straight to the local store, because I can actually buy this one locally. I would drive straight to the local store and buy another one just like it. I mean, when I upgrade stations, like when I spend a lot more money on hot air, it's going to be for like presets and stuff that really, really saves me time. So I'm not sitting here going, all right, click, 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 or holding down the button and watching it count up. For me, a better hot air station is going to mean presets. It really is. So I think I've talked long enough for this board to simmer down. We're going to go ahead and sit it inside of this housing the right way. Now, if I had not already known what this problem was before, I wouldn't have went straight for the housing and stuff. I'd have been unsure about it, and I'd have been checking it. But let's go ahead and check it now. So if we check between negative and positive here, negative and positive here, I get open line 10 mega ohms. So we've gotten rid of our 1.6K short. 1.6K is not a short. Not for 5 volts anyway. Let's go ahead and plug in our antenna connector. Actually, no, because this is all coming right back apart. I got to clean up my mess and put the shield back on it. But for the sake of this video, let's go ahead and hook the power supply to it. There we go. Ground where ground goes. Let me grab me a clip for positive. Now, this is one tool that I don't have in the description yet. I'll be adding those as soon as I get around to finding a link for them, but they're not that hard to find. eBay, Amazon. So this is our ground. We're going to go ahead and set our volts to 4 volts very carefully, because this power supply is junk and it will ruin your life. It hasn't caused me any problems yet, but I've seen the way it can be sporadic, and if those pots get dirty, that right there, that's the difference in 5 volts with dirty pots in that power supply. So we're going to be doing this digital. Okay, so here is our S3 with the fresh IC. Hey, I'm a poet and didn't even know it. And there we've got positive and negative hooked up. I'm showing 3.9 volts on the supply at 0 amps. Okay. And I'm going to hold the board into the housing a little bit, because our power button is actually on the board itself, and it has to match up here if we're going to press it this way. So we got a 1/4 amp, Samsung logo, 300 milliamps. This phone is booting. Yeah, that's probably my biggest complaint with that power supply, is how finicky it could be. It already is a little bit, but it could be a lot worse, man. That supply could really, really ruin your life. So other than that, whenever you're using it for current limiting, it's kind of hard to explain. It puts out dirty power. It's not a real clean supply at all, but for 60 bucks, that sucker has made buckets full of money. Just be careful with it. Alright, it thinks the battery's low, and we're not going to show that to you, because I don't want to reveal my customer. But here we go, a working Galaxy S3, and you can actually see the wires running above my head that go to that light. Alright, so that phone's powered down. The next thing I'm going to do, I use such a little amount of flux on this board, I'm not going to ultrasonic clean it. It's going to get cleaned with, I'm going to heat the board up and I'll use a little bit of alcohol and a toothbrush and compressed air. This will blow off completely clean, and then I'll reassemble the phone and this one will be done. So I know it's been a little bit since the Galaxy S3 came out, but you know, if you got that one person that accidentally blew out some IC on the board plugging in a fan trying to stay cool, this is what happened to the S3. So if I don't know, I was very honest with this person with replacement costs compared to repair cost, and they really wanted this phone fixed. So as long as people are still willing to pay me to fix this stuff, I'm going to keep fixing it, because that really wasn't hard. It was more tedious than anything, but this was a really, really simple problem, so why not fix it? Anyways, that is going to be it for this video. I hope you all have successful repairs. I do thank you for watching, and I hope you have a good day.